Aloha! Today I'll be talking with you about metric prefixes. My computer's extremely slow, so I'm sorry if it's not working. So, why are units important? Let's take a look at this little cartoon that I found. I only weigh 58. 58 in what units? Standard chicken masses, I see. So, units are very important. You could go to the grocery store and expect someone to ask you to pick up 5 cases of eggs, but if you just say, I need 5 eggs, and they come home with 5 single eggs, there's a big misunderstanding, and units are very important. So let's go ahead. We can see here that if you have a video that runs for 127 seconds, you could also say that video runs for 2.12 minutes, 2 minutes and 7 seconds, 0.353 hours, 0.000588 days, or 0.00000161 years. So all of these are the same exact unit of time, but this is being represented in different units. We will learn what the units are right now and the different metric units. And then as we go on, we'll learn how to convert back and forth between these units. Let's take a look at something called the SI base units, which is what we will be using in chemistry this semester and what we should be using for our life, but Americans use the English system, which we will show a comparison at the end. So for the SI base units, if we're measuring length, we would use the unit of meter or a lowercase m. In chemistry, uppercase and lowercase is very important, so you have to make sure you differentiate between your upper and lower cases. When we're talking about mass, we use the kilogram or kg. Time, we use seconds, or the abbreviation is S. Sometimes this can be annoying, so that's why we use abbreviations like days and months and years, but second is the SI base unit. We will not be really talking about electric currents in this class, but with electric currents, they use the ampere or the amp with a capital A. Temperature is measured in a unit called the Kelvin or capital K. It's very close to the temperature of Celsius, which we'll talk about, and it's pretty different than the Fahrenheit unit that we're all used to. We will be getting into substances and amounts with this unit called the mole, and it's a very nice abbreviation because we get to leave the E off when we write MOL for mole. So we'll learn about that throughout the semester. And the light intensity is measured in candela or CD, and we will not be talking about that. One other thing that's important is things will be measured in volume, is in cubic centimeters or centimeters cubed. And 1 cubic centimeter is equal to 1 milliliter, and you may have seen milliliters when you look at your different beverages and things like that. So let's talk about prefixes, okay? We don't just memorize the meaning, but we understand which are bigger and which are smaller. So just to give you an idea of prefixes that make numbers larger, we can get things as large as a iota, zeta, exa, peta, tera, giga, mega, kilo, hecto, or deca. Okay, you've definitely heard of things like kilo when it comes to like a kilogram or kilometer. You might have heard of the term mega, like in megaton or something like that. Giga and tera, we've probably heard of when we're talking about computers, though we don't know what they mean. We might see that a computer has a gigabyte of memory. Does anyone know what that means? Now, if we know what a byte is, we know that's 10 to the 9th or a billion bytes. For this class, we will only be worrying about mega and kilo as prefixes that make things bigger. When we look at things that make them smaller, we have units like deci, centi, milli, micro, nano, pico, femto, and then some other ones, atto, zepto, and yocto, which we've probably never heard because they're such small amounts. Decimeter is something we might have heard of. That's a tenth of a meter. All of us have probably heard of a centimeter and a millimeter, or a milligram. If we're in the medical field, sometimes we hear about things in microgram quantities, and nano and pico are some words that you might have heard. But in this class, we'll just focus on centi, milli, micro, and nano. So you can see all those different symbols, but what I want you guys to be more familiar with is these different values that we see here. Okay? Let's talk about some examples of using prefixes, okay? So let's talk about the distance from Hawaii to Ukiah, okay? If we were to travel as a bird, it would take 3,760,000 meters. Notice how we use the term meter since we're going to be doing chemistry now and we want to do everything scientifically. That is a pretty large number and can sometimes be cumbersome to use all these zeros and things like that. So what we'll learn is how to use prefixes to make that number smaller and use the prefix to account for many of those zeros. Those are using the bigger of the prefixes. We can also use the smaller prefixes. And one thing would be an example is thinking about the radius of a hydrogen atom. So from the nucleus, which we'll learn about later, to the outside edge of the atom would be the atomic radius of a hydrogen atom. And you can see here it's 0.0000000000529 meters. Who wants to say all those zeros? So let's see how we can use prefixes to make these numbers more manageable. So for the top one, the distance from Hawaii to Ukiah, you can see that we have 3,760,000 meters. So we can either use the mega prefix or the kilo. Let's go ahead and use the mega prefix. 10 to the 6, which I'll talk about in a later video, is equal to 1 million. So 1 mega meter would be equal to 1 million meters. So in this case, what we do is we divide our value by the million, and that tells us that the distance from Hawaii to Ukiah is 3.76 megameters. On the lower end, as I said, we don't want to say 0.000, etc. So we have to look at our different conversion prefixes for making things smaller. So what this tells us is, in this case, 1 nano of something is 1 billionth of the size of something. So if we're talking about things in a nanometer, you might have heard of the term nanometer. This has to do with the visible wavelength of light. Instead of, if light was a meter long, it would be 1 millionth of that. So it's extremely small. So to figure out how many nanometers are the radius of an atom is, we would divide this number by the 0.000000001, and that would give us a value of 0.0529 nanometers. So you tell me, would you rather say 0.0529 nanometers or 0.0000000000529 meters? I prefer the nanometer. Maybe you guys just really like zeros and want to use that. So let's go ahead and take a look at these metrics prefix practice problems, okay? So I encourage you guys to pause the video right now and see if you can convert these things, okay? You might have to go back and look to see what the values of a milliliter is, or a kilometer, what milli is, or kilo, or mega, or micro. But let's go ahead and see it. So it takes the time, push pause, see if you can figure this out. And now we'll go through the problems. Okay, so I have all my different conversions on the bottom, and what these 10 to the negative 2 and things like that mean are written on the side. So if I'm going to convert from liters to milliliters, the milli tells me I'm going to use this 10 to the negative third and the prefix lowercase m. In this case, that means it's equal to 0.001. So if we have our 0.0075 liters, we divide by 0.001, and that tells us that we have 7.5 milliliters. Does this make sense? A milliliter is 1,000th the size of a liter. So if we have 0.0075 liters to have 7.5 milliliters makes sense. There's going to be, the milliliter is much smaller than the liter, so it should have a bigger value than the liter. Looking at meters, you can see here that the prefix that we're going to want is kilo. So we're going to use the 10 to the third, which is equal to 1,000. So if there's 74,300 meters that we need to travel, if we divide that by 1,000, that tells us that we would only need to go 74.3 kilometers, which for us may not seem that common, but as we learn in this class, we'll hopefully start to get a better understanding of these different SI units and how they relate to the regular units that we look at. The next thing we're going to look at is if we have something in megabytes, which is a bigger value, and now we have to convert it to bytes. So since mega is a capital M, we look at this and there's 1,000,000 megabytes per byte. So instead of dividing, since we're going from a bigger thing, from a prefix back to the base unit, the base unit would be the thing that that we put the prefix in front of. So the base unit in the first one was liters, and we're going to convert that into milliliters. The base unit in the first one was meters, and we're going to convert to kilometers. When we go from something with a prefix back to the base unit, we're going to do the opposite. So since we have 1,000,000 megabytes in one byte, what we would do is we would multiply the 123 megabytes by 1,000,000, and if your computer can hold 123 megabytes, that really means it can hold 123 million bytes, whatever a byte is. The last one is the microliter, and this is what we call a mu, or a Greek U. It's called mu, and it has a value of 0.00001. So if we're going to convert back to the base unit, we would then multiply by 0.00001. And would it make sense that this 867 of these very, very millionth of a liter would make a very small amount? So when we multiply by 0.01, we get 0.0000867 liters. So in summary, these symbols can tell us the magnitude of a number or measurement, and they will be used to help us in this class instead of making numbers with a huge amount of zeros or a huge amount of decimal places. Thank you for your time.